Techaily.ai, your source for technical information. Welcome to the deep dive. Today, we're taking a close look at the really fascinating world of AI agents, and importantly, the protocols that actually make them capable.
Yeah, the things that let them connect to the real world and, even talk to each other.
Absolutely. We hear so much about these powerful AI models, these sort of amazing digital brains, but getting them to actually do things, like interact with our systems, get information, work together.
That's a whole different ballgame.
Yeah.
It really is. And it throws up some pretty big challenges.
So our mission in this deep dive is really to cut through some of that complexity. We want to unpack the difference between AI models and AI agents, which can be confusing,
That way.
and then understand two key protocols: MCP, the Model Context Protocol, and A2A, the Agent-to-Agent Protocol.
And why they're becoming so essential, really, for building AI systems that are not just smart on paper, but actually useful, scalable, and, integrated.
Exactly. This deep dive is tailored just for you, listener, pulling together insights to give you a clear picture.
Yeah, get you grounded in these concepts.
All right, let's dive in. First up, that potential point of confusion. AI model versus AI agent. People use these terms almost interchangeably sometimes.
You do, yeah. And it muddies the waters.
Yeah.
But they are quite distinct, and understanding that difference is kind of the first step to seeing why we need these protocols in the first place.
Okay, so lay it out for us.
Right, so AI models, think of them as the analytical engine. They're primarily designed to process data, find patterns, generate insights, make predictions.
Like analyzing an image.
Exactly.
Yeah.
Or predicting customer churn. A neural network recognizing objects in a picture for a self-driving car, that's the model doing its thing.
Yeah.
It sees the camera feed, says, okay, traffic light, pedestrian.
But it doesn't hit the brakes itself.
No, exactly. The model provides the analysis, the insight. It doesn't interact directly with the environment. It doesn't have autonomy on its own. It's just processing.
Okay, so it's the brain power, but not the arms and legs.
You could put it that way, yeah. Now, AI agents, they're different. An agent is an entity that can perceive its environment. That could be through physical sensors like cameras or, digital sensors reading data from an API or a database.
Okay, so it takes in information.
Right. And crucially, it can act on that environment using actuators. Again, could be physical, like a robot arm, or digital, sending an email, updating a record, making that API call.
Ah, so it can do things based on what it perceives.
Exactly. Agents are designed to autonomously perform tasks, achieve goals. They operate based on rules or maybe learned policies, and often they have AI models embedded within them to help make decisions.
So like a smart thermostat perceives temperature, acts to turn on the heat. That's a simple agent.
Perfect example. Simple, but it fits the definition. A self-driving car is a much more complex agent. Perceives the world, uses models to understand it, makes driving decisions, acts on the car's controls.
Autonomy is the key word there.
Definitely. The agent is the doer, the autonomous entity interacting with its world, using models as part of its intelligence toolkit.
Okay, that clarifies it. Models analyze, agents perceive and act autonomously, often using models. Models are tools for agents.
You've got it.
Now, let's talk about where things get messy. Well, we have these incredibly powerful large language models now. They write amazing text code, summaries.
Yeah, they're phenomenal at generation.
But like you said, on their own, they're kind of stuck in their digital box. An LLM can write the perfect email, but it can't click send.
Right. Which naturally led to the next step.
Right.
Okay, let's connect these LLMs to tools, APIs, databases, web search, you name it.
To let them actually do things, summarize my actual emails, interact with my spreadsheet.
Exactly. Things like Zapier or other connectors started doing this,
Yeah.
letting the AI reach out and interact with other software.
Which sounds great. Problem solved.
Well, not quite. You solve one problem and run headfirst into another. Fragmentation and, frankly, complexity.
How so?
As you start connecting to more and more tools, this SaaS app, that internal database, various third-party APIs, you quickly find they all speak different languages.
Different API designs, different authentication.
Exactly. Maintaining all those custom point-to-point integrations, it becomes a nightmare. It's fragile. One service updates its API slightly, and boom, your carefully crafted workflow breaks.
Yeah, I can picture that. Scaling seems almost impossible that way.
It's incredibly difficult. It reminds me of like the early days of networking before we had standard protocols like TCP/IP or HTTP. Everyone did their own thing. Nothing worked together smoothly.
And that's where these new protocols come in, to try and standardize things for AI agents.
Precisely. That's the gap they're designed to fill. And the two key ones emerging seem to be the the Model Context Protocol, MCP, and the Agent-to-Agent Protocol, A2A.
Okay, let's break those down. MCP first. What's its main job?
MCP, the Model Context Protocol. Its focus is on helping an AI agent reliably connect to the tools and the data it needs to function. Think content repositories, business apps, dev tools, anywhere information lives or actions need to happen.
So it standardizes how the agent talks to, well, its external environment, the systems it needs to use.
Exactly. If an agent needs to read a file from, say, Google Drive or call a function in your company's Salesforce instance, MCP provides a consistent, standardized way for it to make that request and get a response.
Like a universal adapter.
That's a great analogy. Think of MCP as like a USB-C port for AI, a universal plug that lets the agent connect to many different peripherals, tools, data sources in a standard way without needing to know the specific internal wiring of each one.
Okay, that makes sense. MCP connects one agent to its tools and data, so A2A must be about.
Connecting agents to other agents. Agent to agent, A2A, just like the name says, focuses on standardizing how different AI agents communicate and coordinate with each other.
Okay, so MCP is agent to world, A2A is agent to agent.
That's the core distinction, yeah.
Hmm.
And it's really crucial to get this. They're not competitors. They're designed to work together.
How so?
Well, think about it. You might have several specialized agents working on a complex problem. A2A lets them talk to each other, coordinate the work. But each of those agents might still need to use MCP to access its own specific tools or data to do its part of the job.
Right. So an agent could use A2A to ask another agent for help, and that second agent might use MCP to look something up in a database before answering back via A2A.
Exactly. The thinking is that truly capable agentic applications will likely need both protocols working in concert.
Makes sense. Let's dig into MCP a bit more then. How does it actually work under the hood?
It uses a pretty standard client-server architecture. Your AI application or the agent itself runs an MCP client.
Okay.
And the external systems it needs to talk to. Maybe a file system connector, a database wrapper, an API gateway they run as MCP servers.
So the agent just needs to speak MCP to the server, and the server handles the specifics of talking to, say, the actual database.
That's the idea. The communication itself uses standardized JSON RPC 2.0 messages, usually over local pipes like standard I/O if they're on the same machine, or over HTTP for remote connections, sometimes using server sent events or SSE for more continuous interaction.
Okay, standard web tech. What kinds of things can these MCP servers offer to the agent?
They generally provide three main types of capabilities. First, tools. These are functions or actions the agent's model can decide to call, things like send mail, query database, run script. The model figures out when and how to use these based on the task. We call these model controlled.
Because the AI decides to use the tool as part of its reasoning process.
Exactly. Second, resources. This is about providing read-only data or context. Like, here's the content of this specific file or these records from this database table or this block of text.
Stuff the agent needs to know to do its job.
Right, and this is usually application controlled, meaning the user or the application managing the agent decides what specific context the agent gets access to for a particular task.
Okay. Tools are actions. Resources are information. What's the third?
Prompts. These are essentially predefined templates or structured workflows. They can guide the AI's interaction for common tasks, maybe ensure it follows a certain conversational pattern or asks for specific information. These are often user-controlled or up-controlled.
Like giving the agent a script or a guide for a specific scenario?
Sort of, yeah. So the process usually starts with the MCP client asking the server, hey, what can you do? Discovering its tools, resources, prompts. Then, based on its goals, the agent uses the client to make requests like tools call or resources write.
And what's the big win here? Why go through this trouble?
Oh, the benefits are pretty significant. First, rapid tool integration. It's way faster to plug in a new capability if it just needs to implement the MCP server standard rather than building custom code every time.
Reduces development time.
Massively. And this enables truly autonomous agents that can handle complex multi-step workflows. An agent using MCP can dynamically decide, okay, I need info from the CRM, call that tool, analyze the result, then decide, now I need to send a Slack message, and call that tool via a different MCP server, all within one continuous interaction.
So it turns the AI from just a text generator into something that can actually operate across different systems.
Exactly. It becomes a doer. You also get reduced friction, obviously, better consistency and interoperability because everything uses the same JSON structure, easier debugging, more future-proof. And it supports two-way context, remember? The server can provide prompts and resources to the agent, not just wait for calls. Plus, things like standard OAuth for security are built in.
How does this stack up against, say, the old ChatGPT plugins or frameworks like LangChain? Are they doing the same thing?
It's related, but different.
Yeah.
Custom integrations are brittle, we covered that.
Yeah.
Proprietary plugin systems were often platform-specific and maybe less flexible for ongoing interaction. MCP aims to be an open standard, fostering a wider ecosystem. Frameworks like LangChain are awesome for developers building agents defining tools within their code. MCP operates at the protocol level. It defines a standard communication layer between an agent, however it's built, maybe even using LangChain, and external tool servers. An agent could use an MCP client to dynamically discover and use tools exposed by any MCP server, regardless of how those tools or the agent itself were implemented internally.
So MCP is the standard language they speak to each other, regardless of their internal implementation. Can we walk through an example?
Sure. Let's take customer onboarding. An AI agent needs to verify a new user's ID, create their account in the CRM, and maybe send a welcome message on Slack.
Okay, 3 distinct steps, 3 different systems potentially.
Right. Without MCP, you'd write custom code for the ID verification API, the CRM API, and the Slack API. Nightmare. With MCP, you could have 3 separate services running as MCP servers. One exposes a verified tool, another exposes CRM tools like create user record, a third exposes messaging tools like send Slack message.
Got it. 3 specialized servers.
Yep. The onboarding agent, using its MCP client, first discovers these tools. Then its internal LLM decides the workflow. Okay, first, call verified with the user's details via the ID server. Wait for the result. If successful, then call create his record via the CRM server. Once that confirms, call send Slack message via the Slack server.
And the MCP client handles formatting the JSON requests, sending it to the right server, getting the response back?
Exactly. The agent focuses on the what and when, the workflow logic and decisions, while MCP handles the how of talking to the different systems through those standard server interfaces.
That separation seems really powerful, makes the agent logic cleaner and the integrations more manageable.
That's the core value proposition. Robustness, scalability, easier integration.
Okay, MCP is clear. Now, let's switch gears to A2A. How does that protocol help agents talk to each other?
Right, so if MCP is agent to environment, A2A is strictly agent-to-agent coordination. The central idea in A2A is the task model. Yeah. Any interaction between two agents is framed as a task. Agent A gives Agent B a task to perform. That task has a life cycle. It gets submitted, Agent B starts working on it, maybe it needs more info, and goes into an input required state, and eventually it gets completed, hopefully with some result.
So it's like structured delegation between agents.
Exactly. And within that task context, agents exchange messages. These have roles, like user for the requester, agent for the performer, and they can also exchange artifacts, structured outputs, like files, code snippets, complex data, whatever the result of the task is.
How do agents know what other agents can do?
They advertise their capabilities using agent cards. It's basically a standardized JSON description, like a digital business card saying, here's who I am, here are the tasks I can perform, here's what input I need, and what output I produce.
Okay. And you mentioned something important earlier. They don't share their internal workings.
Crucial point. A2A enforces what's called opaque execution. Agents only communicate via the defined A2A messages and artifacts. What happens inside Agent B while it's working on Agent A's task, its internal chain of thought, the models it uses, any data it pulls using its own MCP tools, perhaps that's all kept private.
So no sharing of internal memory or reasoning steps.
Nope. If Agent A needs Agent B to know something specific, it has to be explicitly put into an A2A message or artifact. This is huge for security, protecting proprietary logic, and even just for debugging, you know exactly what information was exchanged between them.
Makes sense. How does the actual communication work? Is it similar to MCP?
Yeah, it leverages similar web standards, HTTP or HTTPS, and JSON following the JSON RPC 2.0 spec again. A key feature, especially for enterprise stuff that might take time, is built-in support for streaming updates using server-sent events, SSE.
Ah, so the requesting agent doesn't have to keep asking, are you done yet?
Exactly. It can subscribe and get real-time task status update messages or task artifact update messages as the other agent makes progress or produces intermediate results. Webhooks can also be used for notifications, especially for really long-running tasks.
That seems vital for complex workflows. Can the roles change? Can the server become the client?
Yes. The protocol allows for flexibility. Agent A might start as a client asking Agent B for something, but later Agent B could initiate a new task back to Agent A, assuming Agent A also exposes A2A server capabilities. So you can have peer-to-peer or more complex orchestrations, although simple client-server or orchestrator patterns are pretty common.
What about memory? If they don't share internal state, how do they maintain context for a task?
Each agent keeps its own track of the tasks it's involved in, identified by a unique task ID. The protocol ensures messages are associated with that task ID. So if the network drops, the client can retry or pull the server about that specific task ID, and the server knows what conversation it belongs to. But any data needed for context has to be passed explicitly in the messages or artifacts for that task.
And does A2A help with scaling or avoiding getting locked into one AI vendor?
It's designed to. For scalability, A2A tasks can often be handled by horizontally scaled agent services.
Hmm.
Think multiple instances of an invoice processing agent running in the cloud. The protocol itself is largely stateless between requests, which helps. And for lock-in, because it's aiming to be a standard, A2A allows you to potentially mix and match agents from different vendors or sources. You could have a general-purpose customer service agent from one company collaborate with a highly specialized financial analysis agent from another, as long as they both speak A2A.
That interoperability sounds really valuable. Let's do an example for A2A too.
Okay, how about a sales workflow? You have a sales assistant agent talking to a customer who asks, can I get 100 units of product X by next Friday, and what's the price?
Okay, a common request.
But maybe this sales assistant doesn't directly access inventory or pricing systems. It's more conversational. So the sales assistant acts as an A2A client. First, it sends a task via A2A to a specialized inventory agent. Task, check stock, product.x, quantity, 100, required date.
Okay, delegates the inventory check.
The inventory agent receives the task, does its thing, maybe it uses MCP internally to query the actual inventory database, and then responds via A2A message within that task. Status,
Yep.
available.
Got it. Stock is good, now the price.
Yep. The sales assistant then sends another task via A2A, this time to an invoicing agent. Task, generate, quote, product.x, quantity 100.
Different agent, different task.
Right. The invoicing agent processes this, calculates the price, and responds via A2A with the, quote, details as an artifact, maybe a JSON structure.
And the sales assistant puts it all together.
Exactly. It receives the confirmation from the inventory agent and the, quote, artifact from the invoicing agent, combines that information, and presents the complete answer back to the customer.
So A2A enabled these specialized agents to work together like a team of microservices coordinated by the main agent?
That's a perfect way to think about it. Breaking down complex workflows, enabling collaboration, keeping agents decoupled.
This is really starting to click. MCP for tools, A2A for teamwork. How do they fit together in a real system? Give us that hybrid example.
Right, they're definitely complementary. Let's use the IT support chatbot example again. Your frontline chatbot, the one the user talks to first, probably uses MCP extensively.
For its basic tasks?
Yeah. Using MCP tools to search the knowledge base, interact with the ticketing system API, create ticket, update status, maybe even run some simple diagnostic scripts on the user's machine via an MCP server, if permitted.
Okay, so it handles the common stuff directly using its MCP-connected tool.
Exactly. But then, say the user has a really tricky network issue or needs info about specific hardware assets that this chatbot doesn't have direct access to.
Time to call in backup?
Precisely. The frontline chatbot then uses A2A to escalate or consult. It sends a task via A2A to a specialized network troubleshooting agent, passing along the relevant details from the user interaction. Or it sends a task to a hardware inventory agent.
And those specialized agents do their work.
Right. They process the task request received via A2A. Maybe they use their own MCP tools to run deeper network diagnostics or query the asset database. Then they respond back to the frontline chatbot via A2A with their findings or recommendations.
And the frontline chatbot relays that back to the user or updates the ticket.
Exactly. So MCP equips each agent to act effectively in its own sphere, accessing its necessary tools and data. And A2A allows these individually capable agents to form a collaborative network to tackle more complex problems that span different domains or systems.
Okay, that makes the synergy really clear. MCP powers the individual, A2A powers the team.
You got it. They provide that crucial plumbing for building these integrated multi-agent systems.
It sounds incredibly powerful, like it unlocks a new level of automation and capability. But I imagine building these sophisticated agents, even with the protocols, is not exactly easy.
Oh, definitely not. It's still a major undertaking with significant challenges. For starters, data quality and availability. Agents live and breathe data. If your training data is poor, biased, or just not available for the task.
Garbage in, garbage out.
Pretty much.
Yeah.
Your agent won't be effective. Or worse, it could make bad decisions.
Yeah.
We've all heard stories about biased data leading to biased AI outcomes.
Yeah, like recruitment tools favoring certain groups or facial recognition working poorly for some demographic.
Exactly. Which brings us to algorithmic bias. Even with good intentions, AI learns biases present in the data. Actively working against this requires diverse data sets, fairness checks, audits, maybe even specific debiasing techniques. It's a constant effort.
What about plugging these agents into existing company systems? You mentioned MCP helps, but is it still hard?
Well, yeah, integration with existing systems, especially older legacy systems, can be a massive headache. These systems weren't built with AI agents in mind. Getting them to talk reliably, even with MCP standardizing the agent side, requires careful planning, maybe building APIs or middleware on the legacy side. It's often a big integration project in itself.
And making sure they can handle the load.
Scalability and performance, absolutely critical. If your customer service agent falls over during peak hours, that's a disaster. You need to architect for scale, often using cloud platforms, containerization like Docker or Kubernetes, and constantly monitor performance.
And this all sounds expensive.
It can be. Cost and resource constraints are very real. You need skilled AI engineers, data scientists, good data infrastructure, significant computing power for training and running these things. It's a serious investment. Starting small, maybe with an MVP, and using existing platforms can help manage the cost. But it's not trivial.
Plus, the world keeps changing.
Right. Continuous learning and maintenance. An agent trained today might be outdated in 6 months. You need processes to continuously monitor performance, retrain with new data, update models, and adapt to changes in the environment or the tools it interacts with. It's an ongoing life cycle.
And then there are the rules and ethics.
Always. Compliance and ethical concerns are huge, especially with data privacy laws like GDPR or IPI. How does the agent handle personal data? Is it transparent? Is it being used ethically? Avoiding issues requires careful design, strong data protection, clear user consent, and staying on top of evolving regulations.
Okay, that's a sobering list of challenges, but important to acknowledge. So, turning to solutions, what are the best practices people should follow when developing these agents?
Well, based on experience and what seems to work, a few key practices really stand out. Number one, define clear objectives. Seriously, know exactly what you want the agent to achieve. What specific problem is it solving? What are the measurable goals? Vague objectives lead to wandering projects.
Be specific. Makes sense.
Second, and we keep coming back to this, focus on data quality. Clean, diverse, representative, unbiased data is non-negotiable. Invest the time and resources here. It pays off enormously.
Third,
Adopt agile development methodologies. AI isn't usually a waterfall project, it's iterative. Build a small version, an MVP, test it, get feedback, refine it, add features. Use cycles like Scrum or Kanban. Learn and adapt as you go.
okay, iterate quickly.
Fourth, invest in robust security measures. From the start, secure authentication, data encryption, at rest and in transit, access controls, regular security audits, especially if the agent touches sensitive data or systems. Don't bolt security on later.
Crucial. What about the user?
Absolutely. Fifth, prioritize user-centric design. If humans interact with your agent, make it easy and pleasant to use. Is it intuitive? Does it understand intent well? Is it responsive? Test with real users, get feedback, keep it simple where possible. If conversation is involved, leverage high-quality natural language processing, NLP. Good NLP is key for understanding user intent, handling variations in language, maintaining context, and generating natural-sounding responses.
Makes the interaction feel less robotic.
Exactly. Seventh, monitor and evaluate performance regularly. Once it's live, you need dashboards, metrics, logging. Track how well it's meeting its objectives, look for errors, understand where it struggles. Use this data to drive improvements.
Catch problems early.
Yep. Eighth, actively test for bias and ensure ethical use. This isn't just about the initial beta. Continuously monitor the agent's outputs and decisions for unintended bias or unfairness. Have ethical guidelines and review processes in place. And finally, ninth, maintain compliance with regulations. Laws change. Stay informed about data privacy, AI regulations, industry standards. Build compliance checks into your development and monitoring processes.
That's a really solid set of practices. It highlights that building good AI agents is as much about process, data, security, and ethics as it is about the core AI algorithm.
This really is a multidisciplinary effort.
So, stepping back again, looking at MCP and A2A and this whole ecosystem, what's the big picture value here? Where is this heading?
I think the big picture is that these protocols are enablers. They're tackling the foundational integration challenges, the plumbing, that have historically made it hard to build AI systems that can truly operate autonomously and collaboratively at scale within complex environments.
They make the vision of interconnected, capable AI more achievable.
Exactly. They lower the barrier to connecting agents to the tools they need, MVP, and enabling agents to work together effectively, A2A. This fosters an ecosystem where you can build more sophisticated, specialized, and integrated AI applications. And like we discussed, the line between a model and an agent gets blurrier. It becomes more about the overall agentic application and its capabilities enabled by these underlying standards. We're moving from isolated AI brains to integrated AI systems that can perceive, reason, and act in the world.
It really feels like a shift towards AI becoming a more active participant in processes rather than just an analytical tool.
I think that's a great way to put it. These protocols are key infrastructure for that shift. And that leads me to a final thought, something for you, the listener, to maybe chew on. If these AI agents, using protocols like MCP and A2A, become truly autonomous and collaborative, if they can form their own dynamic teams on the fly to tackle complex business problems, what does that mean for how we structure work? How might our own human teams and job roles need to adapt when agents can increasingly self-organize and execute significant parts of the workflow?
That is definitely something to think about. The potential impact on organizational structure and human roles is profound. A fascinating place to leave it. Thank you for joining us on this deep dive into the world of AI agents and protocols.
My pleasure. Understanding these foundations now feels pretty critical for navigating what's coming.
This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged and VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.